Okay, great. Well, thanks for having me here. I really appreciate the invite. It's wonderful to speak to you. I'm always excited to speak about these subjects. And today I'm going to be speaking about how to craft your data, bring it together for artificial intelligence workloads, because that's also important to us nowadays. So a good place to start with this story is just taking a step back and considering what data really is, because we kind of get a bit lost in the weeds now in terms of what data is. We think of tables and we think of graphs and we think of charts and we think of mathematics and all sorts of different constructs of data to represent information. But really, data itself is a pretty old concept. The first recorded known, currently the first recorded known piece of data which is used for any sort of computation were the Kish tablets of ancient Mesopotamia. And that was 5,500 years ago. Supposedly, we think at least that these little tablets of clay were used for trading. So they could probably teach modern day traders a thing or two as well, I have no doubt. So this is not a new concept by any means, the imagination. And of course, the transfer of information must have gone an awful lot longer than that, must have gone on an awful lot longer than that ago, because in order to even get to this point, there would have had to have been the pass down of knowledge and information for a very long time, even to agree on the symbols that you're going to use to transfer information. So really, ever since human beings could communicate in any form, data has been used to transfer knowledge. But it's not much good unless you can actually understand it. Indeed, it was only relatively recently that we even understood what hieroglyphics meant. If we take reference, of course, to the famous tablet. So, without understanding and without translation, without understanding the meaning of the symbols and language which you're using to represent knowledge, it's really not much good. So that's the way we've evolved as a species to communicate and understand data. And then after all of that, after however many hundreds of thousands of years of evolution of working out ways of transfer this information, we then started to invent new ways of recording it. And but what are all these things based on? All of these formats of language and all of these ways of recording data are based on standards. And we haven't actually been particularly great at sort of creating new standards in recent years. In fact, one of the most popular forms of standards used for computing is the QWERTY keyboard. And that was first invented in 1878 as a means to prevent you from recording data too quickly, because typing too quickly on the original keyboards would have broken the machine. But we're still using that today. So we haven't exactly been particularly intelligent sometimes about creating and using and reusing the right kinds of standards. Now, so what happened with computing was really quite interesting, because we then created this new kind of way of recording information. We kind of tried to create data in a new way to try and represent data for computers to work with. And we created lots of different ways of recording data in new ways for computers. We created things like tables, we created key value stores and document stores. And for those of you who are familiar with relational databases, they've become probably the most widely used storage mechanism for computer science. And we created this whole new structure for recording data for them. And really, we did that so that we could compute things from a computer's architecture in a efficient way. We weren't really thinking about the transfer of information as its primary function. We were thinking about how to perform computer computations on data, on mathematics initially. And what this creates is this almost a new kind of meaning, a new kind of language, and something new you have to translate every single time the data model is created. So if you create, for example, a data model about your employees, the products that you're selling and the orders that are made, such as the example on screen, that model, that general structure of the data would be different in many different organizations, even though it's representing the same kind of data. And indeed, even within the same company, there'll be different models that contradict each other for the same kinds of data. So this isn't really particularly good for being able to translate and transfer information. As a consequence of that, going back to what this means for artificial intelligence, this is one of the main reasons that we know that 95% of all the generative AI startups that we know of have in fact failed from their funding, and a lot of this is down to do with data and preparation. So how do we do it properly, and how do we do it intelligently? Well, we kind of need to evolve. We can look at those who've already done it reasonably effectively, and we can try and evolve our own enterprises to adopt the same kind of strategies. So if you think about those who are have the most advanced computer systems now that use artificial intelligence most effectively, they're the companies really with the deepest pockets, of course, and those who've had the most resources thrown at them. But they've evolved their thinking from thinking about these different types of ways of storing data from those relational models, from the flat files of the 1960s, which you see in the bottom left, which is these sort of tabular forms, into these tabular forms, and then taken this into more integrated, more intelligent ways of representing data, all the way up to things like knowledge graphs and then vector stores. And what we're really trying to do now for enterprises, and what enterprises are trying to do, is combine these kinds of technologies together to create something which is a lot more closer to language and meaning. Something whereby the structure is not restrictive to the way that data is understood and stored, but something where the data really can be linked across many different places. And this kind of system that we're talking about is what we call neurosymbolic artificial intelligence. Neurosymbolic artificial intelligence is about the combination of generative AI, which you'll understand to mean things like large language models in many contexts, ChatGPT, Gemini, and all these kinds of things. And combining that with your own data is giving it some sort of structure, some sort of factual information based on a structure and a language which the generative AI can understand. So what does that mean? That means we need to create a structure of information which is understandable to language. So if you think about the way a language model is trained, it's trained on our way of communicating, it's trained on language. But if you think about the way that those data structures were formed originally, they were not created for that kind of interaction. They weren't language. In other words, they cannot translate things between one another natively. There is no Rosetta Stone that has been discovered necessarily for that. So what we need to do is we need to make those languages interact. And to do that, we have to have a form of data which itself behaves like language. And this kind of system is created by combining what we call a knowledge graph to language models, or generative AI as it's called in this slide. So I'll try and go through a little thought experiment to try to demonstrate what this means and how this works. Let's say that we have a relatively straightforward use case for a new application, and this application is about finding venues for people to go and visit when they're on a holiday. If I present a question like, and a statement similar to that which you have on the screen, Bob is on holiday. He wants to visit an art gallery, and where should he go? Now, we all, as human beings with a deep understanding of language, fully understand those three simple statements or questions. We know that Bob is a person. We know there's something called a holiday, which is a thing that people go to. We know what an art gallery is. We understand the relationships that are represented. But if you think about it a bit more deeply, there's an awful lot of data and information going into these three statements. But we, as very developed language models, are able to understand that just as a large language model is now, because we have so much reference information and we have a graph of knowledge which extends beyond these concepts, so that we understand the meaning of these questions. But if we try to answer that kind of question from a traditional relational database, just from looking at it as a language model ourselves, I think it would be fair to say it would be pretty hard for anybody here to be able to answer this question very quickly without doing at least a reasonable amount of analysis on this. And why is that? Why is it so incompatible? Well, we've already touched on some of the reasons, but to reiterate it a little, much of the structure here which you see has nothing to do with the information. In fact, it's about 70% of the data which you see here is actually just metadata and noise in order to create a new structure to represent the data itself. So in the real world of information, there's no such thing as a table or as a foreign key or as a reference key or a primary key or a column or a row. And then on top of that, there's no such thing as a structure between tables to decide how to relate things together. The way that language is structured is actually much more direct. The relationships between things themselves contain meaning. So to answer this question, as you can see from this, is actually quite difficult. But if you put this data into a graph, the answer can come to you almost immediately. And why is that? Because a knowledge graph is structured in the same way as language is, and it's built around the information being everywhere. Every relationship in the graph is itself part of the meaning, part of the data. So we don't need to create a new abstract structure in order to represent this data. We can just record it as is. So we can look at this graph and see that Bob's interested in the Mona Lisa, which is exhibited at the Louvre. Hopefully it's still there, which is located in Paris. So we want to create a knowledge graph in order to interact with language because they're represented in very similar ways. And you don't really need to take necessarily my word for it either. If you went and asked a language model directly itself, what kind of data storage mechanism you wanted to use to represent complex linked data or complex data of any style, it will tell you to create a knowledge graph. So how do you go about creating that? Well, as you well know already, I work for Amazon Neptune, and we provide a broad set of tooling that assists in this. Some of those highlighted here. There's a product called graph.build on the AWS marketplace, which you can use to visually create knowledge graphs from data which already exists. And you can also use things like the Graph Explorer, which is an open source tool for clicking around and exploring the graphs as well. So in order to build them, in order to store them, and in order to create them, much of the code is taken away from even being necessary for simple use cases. And we provide lots and lots of other tooling to integrate to create your knowledge graphs. So I hope that's interesting. I'll open the table up to questions.
Charles?
I've got one. Yeah. Hi, Charles.
Hi.
So you know, and I know that organisations don't tend to have a single source of the truth. Yeah. So they've got many systems, many databases. Some of it complementary data, some of it conflicting. So how does an organisation go about using the graph build in that situation? Are you assuming that there is a single master data set, or What do you need to do?
So let me see, in fact, if I can show you an example. So what you need to do basically is connect to the existing data sets that exist and then link them to your graph. And you have a choice then of a few different scenarios. In fact, I'll share my screen and show you. So I think you can see my screen now. So this is the graph build interface, for example. And what you can do here is you connect to existing data which already exists. That doesn't mean necessarily that you need to connect, that you need to create. It doesn't necessarily mean that you need to create new data and store it in your graph. Sometimes you can even leave it where it is. So you have options. But you do have to create a mapping. You have to say, well, this is the data where it's coming from. So in here, for example, we have this, one of the places of data for this knowledge graph is coming from a SQL database. So we connect to it. We can see the output results of that data. And there is obviously some sort of task for a human being, or in many cases now for an agent, for an AI agent, to create a mapping between the data which is coming in from wherever it is and the graph which is coming out. So if you could imagine that part of this graph, this particular graph is about credit card transactions. So part of this graph you could imagine was coming from one place, maybe this particular thing, which is about the devices that have been performing transactions like your phone or whatever. And some other information is coming from a different part, then you can link another part of the graph to a different part. And all of it comes together to form one larger ontological model, one larger ontology, which might in the end combine things like about the credit card, about the people, about the organizations that were selling things, and so on and so forth. So you could almost imagine that looking at this diagram, everything of a different color is coming from a different place to be combined together. But that doesn't mean that you have to duplicate the data. You can leave some of it where it is, or you can materialize it and create it as well. So customers create knowledge graphs as a combination of data where it currently exists and data which is actually pulled into the graph anew from different places. So Graph Build provides a nice user interface for being able to do that.
And I have one question about that. So can you hear me?
Yes, I can hear you fine. Yes, thank you.
I need to know about what is the different about the flow chart and the mind mapping thing on that. When you are storing or data things on that.
So yeah, okay. So that's a very good question. So we're looking at almost two different concepts here. We're looking at the ontological model, the ontology, which is kind of how things are related to one another. So it's, in a way, it's your initial logical model of how you want to represent the data for your organization. So every different organization wants to represent their data in very, very slightly different ways. And although they will be very similar, and you can reuse publicly available schemas, if you like, logical models, of which, by the way, there are thousands, and I'll touch on that in a minute. You want to create some sort of logical model that represents data the way you want. Right? So this organization that we're looking at here, they know they want to record data about transactions, about payment terminals, about credit cards, and they have these specific fields that they want to facilitate. So that's how things are related and why things are related together, the logical model. But then how does that become a physical model? And that's really what we're interested in, is because without the physical, there's no real instances of this logical model. So once you've created this, you can then go and graph build to create the physical models that join to that logical model. So I've created that logical model about credit card transactions. I can then go and create a physical model that maps to that logical model. So this provides us a way to be able to say, well, this is a transaction. This is going to become a transaction for my logical model, and I join it. And then as a consequence, I've created my physical graph from the logical.
So it's just like we can use the flowchart for like the when we are design the coding perspective, right? Is that
yeah, so effectively the coding's done for you, so it's all data driven at this point. So you've effectively you've already got your ETL pipeline.
What is the correct path on that? Identify the possibilities on that.
Let them talk. You let them talk,
Yeah.
and then because I think there might be a bit of a delay.
All right,
Okay.
all right.
Sorry, Charles, you said that again. I think there's been some overlap there. So you just repeat what you were
All right.
saying, and then you can probably respond.
Yeah, no problem. I was just saying that yes, a lot of the coding is basically taken out of your hands in that you don't need to do it. It's very data driven. So you can concentrate on building the applications that use the knowledge graph rather than building the infrastructure that will create it.
Thank you.
Yeah, that's right.
I've got a quick question with regards to this. Part of the preparation for AI would be understanding the location of that data, also the sensitivity of it. I mean, you mentioned credit card transactions and everything there. Got lots of other legislation that's coming along with regards to where that data might be. So when you're looking at this at the moment, how would you govern that data so that it's being accessed from the right point, that it doesn't contain any PII, all those kind of things?
Yeah, right. It's so that's obviously as I'm sure you appreciate, a much more quite a complex question, really. Everything can be stored. So from a functional perspective, everything can be stored as something which is obfuscated if necessary. There are also partners that we have whereby they're developing graph technologies where you can link to other knowledge graphs and perform reasoning about things, perform computation about things, for example, without even knowing what it is you're looking at. So if you wanted some sort of aggregate metrics, perform some sort of algorithmic processing over graphs across different organizations without having to know what the data is, we can do things like that. But I'd say more importantly and overarching, I'd say that there's data management principles and ways of working which you should employ as an organization to ensure you adhere to all of those good working practices for upcoming legislation and existing legislation.
I think as well, sorry, you've got particularly, I mean, I get what you're saying with the example there, but you've got a danger there that you connect into sources, you connect into content that you don't necessarily know what that content is.
Presumably, there's still requirement for privileges, access privilege.
Well, that privilege would be governed by your AI model. So, for example, if you connected it to a HR store, something that had personal information in there, you may ask a question of your GenAI tool, whatever it might be, and then it will suddenly bring back data that you never even realized was there. And privilege doesn't come into it.
Yeah, it raises a really important point. And the one good thing about having a knowledge graph in place is, of course, you get to govern at least what's in it and the access to it. So one of the things you can do with knowledge graphs is you can actually join graphs together themselves as well. There's an automated mechanism for doing that. But at the same time, you can use fine-grained authentication to restrict access to certain people to certain things. So there are mechanisms which I'd love to dive into at another time, but there's some online resources you could go to see how to do that.
Apologies, it's a big question, so apologies.
It is, yeah, no, it's absolutely fine. It's a great question though, and what I would advise actually, if you can, is to join organizations like the EDM Association, which I think I'm sharing on screen. Am I still sharing my screen?
Yes, you are.
Yeah. These guys are collaborating together to come up with standardized models and processes to follow to ensure that all of those kinds of I don't know, what would you say, principles are adhered to. So they provide frameworks of working that other organizations have agreed upon to have common models so that you can ensure that your data management principles are up to industry standard. So some of the biggest organizations in the world have joined some of these groups in order to try and innovate and create these things. So and membership for these things is not particularly expensive, that sort of thing. So they always welcome new people.
Thanks, Charles. Well, a question from Stephen online. Stephen, a message you back. Do you want to ask your question yourself, or shall I? It's in the chat. But there, Stephen, you should be able to unmute if you wish. No. Okay. I'll read it out anyway. We're a local government, so we have lots of systems that contain data about intersecting entity populations. For example, people, locations, buildings, vehicles, etc. Presumably, we could create a processing layer that would identify where entity A in system 1 is the same as entity in system 2, and then use that to feed our graph.
Yeah, absolutely correct. Identity resolution is in itself a science. So there is certainly, if identifying things as being the same is complex, then graphs can be really, really useful, because graphs can create a sort of fingerprint, sort of semantic fingerprint of similarity. If you think about a sort of network of connected things, you could decide that if something has so many things connected which are the same, then you could decide that they are the same thing, that sort of thing. So entity resolution itself is a process, and yes, that is absolutely a very big part of it. Sometimes it's easy because, you know, if you're connecting people by their driving license number and you have it from both systems, that's pretty straightforward. But if it's that you're trying to identify someone who's got a very similar name to many other people, and you're trying to identify them as part of a social network or something, then graphs can be very useful. I did a talk last year for the Department of Workplace and Pensions, where I showed a demonstration of a graph, which I still have a video for if you'd be interested to see it, of creating a knowledge graph to identify benefit fraud by joining together information from different systems to you know, to try and ask questions and of, you know, if somebody, you know, trying to identify somebody who is both employed and claiming unemployment benefit at the same time, you know, without necessarily wanting to know their personal details, you know, that sort of thing.
Wow, certainly, I'd be very interested to see that video. If, you know.
Question.
Go ahead. Yeah.
Yeah. Hi, Charlie. I'm OG. Just want to ask, yeah, where does RAG come in, or if RAG is integrated in the whole system? Yeah.
Yeah, RAG is a very interesting piece of the puzzle as well. We haven't talked about it at all today, really, but it's a broad topic because the term resource augmented generation is itself a broad topic. But most of the time people are talking about unstructured content when they talk about RAG. So what I mean by that is get a load of documents, say PDFs, Word documents, whatever, without any structure. Today we've really spoken about structured content to a certain degree, right? You're taking data from SQL databases, spreadsheets, that sort of thing. The other side of that is the unstructured stuff. Documents, PDFs, whatever, emails, I don't know, something like that. So those tend to go in RAG systems. One of my friends, a good friend of mine, who has been developing a graph RAG system for AWS, which does exactly this. It takes all the documents that you could throw at it and then will create a lexical graph, basically creates a knowledge graph of everything, which all the sentiment and meaning and the facts that exist within the graph. And it basically creates a graph of facts and supporting statements. So you have like a fact, like, you know, I don't know, I can't even think of an example now, but you get a fact in there and it says, you know, Alan Shearer scored for Newcastle. And there will be a bunch of supporting statements saying that that's true, and you'll be able to see how confident you are that the statement, the fact, is true. Because understanding information from unstructured content is much more subjective. And that's really where RAG systems fit in. But then if you combine that with your sort of ontological model, which I was describing before, that logical model, you can start to integrate the data between your RAG system, your graph, those sort of sentiment and statements about things, and the real data itself. And in many ways, that's where you get to those neurosymbolic systems being quite evolved, because you have a combination between the unstructured document data in your graph RAG system and your structured graph for a neurosymbolic system.
Okay, thank you.
Any other questions we've got in the room, or any other questions online for Charles?
Well, I have a question. It's not really a question. I just I'm working on a literature paper at the moment using AWS as a POC, and I'm wondering whether you'd be okay for me to reach out to you to basically validate some of the ideas that I'm putting in place. It's about standardization of color scheme, which AWS is actually using. After my research at university, a year later, I saw it implemented in AWS. And so I want to extend that. So I'm trying to find a way to find some kind of validation through your company. Really.
Yeah, absolutely. I'll be delighted to help. Reach out to me. I think on one of the slides I had was my LinkedIn profile. I'll share that with you as well. Please reach out to me and just contact me through there or through my email. I don't mind.
Cheers, appreciate that.
Charles, is there a trend in what organisations are taking a kind of looking at this point in time, and what use cases they're applying it to?
Yeah, I mean, really, it's too broad to necessarily pinpoint down to a certain thing. Typically, knowledge graphs were originally used by the companies with the deepest pockets. So, and with the largest amount of resource, shall I say? It's probably a better way to put it. So, Google, Facebook, Amazon, name a top tech company, and their technology stack is based on graphs. As I'm sure you're well aware, you've heard of social networks and things like that. These are all different graphs of a different kind. So it's very easy to find examples, but if you wanted specific case studies and stuff which you're interested in specific sectors, then I'll be happy to help you pinpoint.
Thanks.
I can help you with that as well if you want.
Okay. So where does one go next, Charles? So if you wanted to kind of do your own, proof of concept or trialing or whatever, where would you suggest that somebody would go next to kind of get their hands a bit dirty or a bit hands-on?
Well, if you wanted to work with a partner, then to sort of help you through the process, then I'd recommend. I could recommend a few, like Orteca in the UK, a really good partner for this. I'll put their name down in the chat. But really, if you wanted to build yourself, you can go to Amazon Neptune and follow the resources that are there. GraphBuild provides some great resources. There's some blogs which are coming out, and so yeah, it depends how much you want to get your hands dirty, so to speak, or how much assistance you'd like. Why don't I send a few things on an email to you about how to get started? There's also a bunch of tutorials that I've written and others have written about this technology stack. So I've been doing this for about 20 years, which is longer than most. I founded a couple of startups myself in the industry. I think you can still see my screen. So I could, for example, go to, let's see. So I don't know how many of you are familiar with Jupyter Notebooks, but Jupyter Notebooks provide a sort of experimentation area. We've written a load of Jupyter Notebooks to teach you how to create graphs. So if you wanted to, you can download this open source technology, run the notebook, and then in there you'll be able to see, go through a tutorial of exactly how to create a graph. There's also some documentation which we've written about how to create, let's see, what have I got here? Yeah, there's some stuff that I've written here. So there's some full tutorials of here, which are more conceptual than anything else, just to describe actually the technology. So to step through this, you don't actually need any technology, but it just runs you through how the process works and that sort of stuff. So there's lots of resources available. Let me share a list.
Yeah, that'd be great. Yeah, and then we can share it as part of the notes then, can't we?
Yeah,
and that'd be really helpful, because I think you know, it's from my perspective and industries I've come from, we all know that data. We've always known that good data is necessary. You know, the old adage of garbage in, garbage out. But it's beyond that now. It's like processes are automating based on the data sets that they've got, good, bad, or ugly. Really, it's just happening whether you like it or not. Really, so I think those that have been in the game or in the IT game know that the data needs to be good and needs to be modeled in some way. So it'd be really helpful to see what that looks like. But what was interesting for me, though, it kind of your discussion came full circle, because I think somebody asked a question about joining together the same data. I think it was Stephen online asked that question.
Yeah.
Of course, that data mapping is kind of what you would do way back in time, really, when you were moving data from one place to the other. I mean, you know, so those fundamentals don't change, do they? But of course, the tools that are available to do that, to take advantage of the next step of the large language models, is the key piece here, isn't it? I think.
A quick one.
Yeah, that's right.
Yeah.
Sorry, go ahead.
I'm just asking, just with respect to the question that was asked online, in terms of application and interpretation of these graph system, you know, if we're to go with what Simon asked, now how do you present after deploying your graph? How do you now present to different layers of persons? For example, you want to present your data to the common man on the street. Okay, these are what happens. How do they interpret your final output?
Yeah. How do you visualize it in a meaningful way? Right? I think so. For me, the most obvious, the easiest one is Graph Explorer. So the Graph Explorer is on Amazon Neptune, is basically a way that you can search for anything and click around. In fact, why don't I, if we've got enough time, if we've got another 5 minutes, I could show you that video which I've got, which uses Graph Explorer and GraphBuild a little bit for that use case, for exactly this. So just to provide you a sort of end-to-end example. Would you like
10 minutes here? So yeah, definitely.
All right, let me see if I can dig that out. Bear with me a moment.
Yeah, thanks, John.
No problem. I've got to find it, of course.
That's typical.
Yeah. Okay, here it is, I think. Oh yeah, I have it. Let me just see. Hopefully a video will kind of work on this sharing screen, watching a video thing. I'm quite sure.
You might need this to drop the sign. We'll see. Here we go. Yeah. I just and check me.
Okay. Let's give this a whirl. So I'm going to try and talk reasonably quickly while I'm doing it, because it runs on at quite a pace. So to set the scene, this is a use case for the Department of Workplace and Pensions for fraud detection in the case of benefit cheats. And yeah, this is the Neptune homepage. Just a lovely visual, isn't it? Just give me a moment. Right, so this is an example of graph build. So this is what graph build looks like. So in here, somebody has designed an ontology. This ontology being the sort of schema, the logical model. So we have people, benefit claimants, claims, employees, and employers. And what we want to do is combine data from two different systems. One which is the employment records from one system, and one which is benefit claims from the DWP. So you could imagine the two, HMRC or something, and yeah, I know DWP. So you can imagine those two things coming from two different places, and we need to link it together into the same place. So we take the data from those two different places. Now, because we have that ontological structure in place, and we fed in data through the graph, through graph build, as I was showing you, into this ontology, that means that I can also ask the language model, what is it that I can talk about? So I can say to the language model, I can basically give this ontology to the language model and say, this is the world that you're working within. That means that the language model, in this case being Claude, but it doesn't really matter which one it is then able to ask natural language questions immediately of that actual data, because it's been fed in and it understands that model, it understands that context. So I'm able to then ask a set of questions such as list all the individuals who are currently employed and also claiming unemployment benefits. Find all the claimants who are claiming more than one kind of benefit at the same time. So remember, this is actual natural language that I'm asking directly of the actual structured data. So without having to, without really having to write a word of code, just by doing some mappings and creating a graph, we're able to get a language model to interact with some real data. And one of the biggest benefits of this is that any answers that come back from this are coming back as real data. You're not going to get hallucinations here. The answers that are coming back are coming from queries which are generated based on the ontological, the logical model that was created. So there are really some quite complex queries that can get created here. So finding all the individuals who employ employees and claiming employment benefits. And we can find in this example that somebody called Anne Burgess Ward has been seemingly up to no good. So then, because it's a graph, we can go and explore from that point in the Graph Explorer. So we can then go and search for Anne Burgess Ward by name. We can find her as a node in the graph. We can see all the metadata about her. And then we can go and explore from that point. So we can look at her on the graph, open that up, and we can see that she is making these different claims and she has an employer and she's working for that particular employer, Smith, Williams and Co. We can also see that there is another benefit claimant here who also works for the same employer. So we can start to sort of draw some connected picture, do some analysis of maybe some sort of collusion between different participants. And that's it.
Can I ask you, how is it similar to using MCP, a model context protocol?
So MCP really is more like, if I was to go back to this point here, you can see here that in this video, if I can highlight it, I'm not sure I can, but right in the middle, you've got sort of things like, you can see there's a Neptune endpoint, right in the middle of the screen. If you can see my cursor, I don't know. And and above that, there's an S3 key. So that S3 key, what's in S3? If you read that string to the end, you'll see it's called a benefit fraud ontology. You could imagine that in a more complete system, which isn't just this demo that I hacked together, that S3 key, the benefits fraud ontology, that might be behind an MCP server, which is the MCP server for the ontology, for the logical model. And the second one, the Neptune endpoint, that might be an MCP server for the Neptune endpoint. Really, what all the MCP is, it's a resource that you can go to ask a language question of, basically, and it describes it. So you can imagine that those two might be MCP servers, or in a much more advanced system, maybe they'd dive much deeper into specific aspects of the graph.
Okay.
Okay. Any other questions in the room? We've got about 5 minutes left of Charles's time allocated, but I mean, we can stretch it if we want to, but yes, question at the back of the room. Yes.
Sorry, so how does that system differentiate between universal credit claimants? Does that make sense? That can work, and obviously other benefit claimants that can't work?
Do you hear that
Well,
question?
the data, yeah, I did hear that question. It's a great question. The answer is the data has to be there to be able to answer the question, for sure. And what this sort of system is able to do, because it knows the context of the ontology, so we know what data we have and what we don't, we would at least be able to say we don't have the data to answer that question rather than make something up. So one of the problems that you might get with other with AI systems which don't have a ontology attached to them is you won't be able to specify that it won't be able to necessarily be honest about what it has and what it doesn't has, but we're working with actual data here, so we won't be able to hallucinate it. So that helps. But you certainly need to have the information there to be able to know.
Well, for me, you mentioned hallucinations, and yeah, I get that. But what about, how would you manage the drift and any bias that would start to appear?
Well, we're not asking the language model yet in this particular example for some sort of opinion. We're just asking for the data. In fact, we're just asking it to create a query that will give us the data. We're not saying, what do you think of that at the end? So, of course, you need to have fairly deep understanding of what your language, just like any agent that you may have that's working within your organization, in order to stop them from being biased towards one particular perspective, you have to have controls in place. Because as soon as you ask for an opinion of any language model, human or otherwise, it's going to give you one, isn't it? So, yeah, it's a very. Do you know what? I think that's probably something we can have a whole conversation about on its own, isn't it? For probably a few hours.
That's two of them now.
Yeah.
I think from what you said there, you're right, because if you were to change that model to say, look at the propensity for a new claimant to be fraudulent, I think that would be probably where you'd get more chances of drift or bias.
Yeah, exactly. As soon as you ask the language model to form an opinion of the response, so even if it's just like, tell me who's most likely the worst benefit cheat, it will still create a similar query, but then it will form an opinion of the data that comes back and then present you with its opinion. So as soon as you're asking for an opinion rather than just seeing the results. So in this particular example, we're not even asking for an opinion. We just get it to do the translation, basically. We're using it as the Rosetta Stone to translate between the languages and then get the answer back, but not interpret it. So we just use it to ask the question, then we look at the result rather than get it to interpret it. So yeah, as soon as you ask an opinion, that's where bias comes in, which I suppose is just a true statement, isn't it?
Thinking of a slightly different example where instead of employers, you've got schools and you've got results, and then opinion, maybe emotive in that case.
Yeah, I think that's a very good example of where you definitely wouldn't want to hear the opinion, you just want the results.
Exactly, but it wouldn't be good.
Yeah.
Well, I guess then just following on from that about bias and so on. We talked earlier about data security and about permissions. So when you build one of these models, Charles, I'm guessing the model itself gets locked away according to permissions and isn't going to get gobbled up by some other nefarious.
Yes, that's right. So absolutely. So the actual data itself here is not even exposed to the language models. So using Claude in this scenario doesn't mean that Claude has any access to the data. So that all stays within your own estate.
Can I just ask how much detail on an individual basis is and different categories in commercial enterprises, maybe particular in your work for Amazon? how do they construct models and to what depth on an individual? I imagine it's quite in depth and maybe not very nice if we knew the details. And curious if you could share.
Yeah, it would depend on the specific use case. I think I don't even know, to be honest, about the depth of which models go where. I tend to work with AWS's customers rather than Amazon as a company. And even if I do engage with Amazon, it's as a customer almost to AWS. And it's very rare, really, that we get exposed to any data. So it's difficult to say how deep the rabbit hole goes, so to speak. It's good to know, though, that at least there's legislation in place to ensure that where you do have personal data, if you want to get access to it, you can these days. That, my personal opinion, I think that's a good thing. So yeah, it's a great question. Who knows?
Yeah, I think that's, I mean, in terms of data privacy and so on, obviously everybody's quite concerned, aren't they?
Yeah, of course, yeah.
It's no worse than what you've got in an organisation today.
It is.
Is it?
Oh,
Right.
yeah.
Look, if I'm a corporate organisation, I've got personal data, right, about customers, employees. You know, I could be a school and I've got safeguarding data, and you've got all that information, and you're not allowing people to see it, right? And it's probably on relational databases. Yeah, you're not exposing this data. You're just reformatting it and putting a graph against it to be used within that organisation for its purposes. It's not being ported across. To me,
it's not right. If it doesn't exist, you can't create it out of nothing. But also, if you look at
really sensitive data in my organisation, I've got to control it, I've got to manage it. But this gives you the ability to get to it in a different way.
I agree with you on that, but from a very, very simplistic perspective, you would say, okay, I've locked this down, I've got my relational, I've got my, systems of record, I've got all this PII and what have you, personal information, whatever it might be. And I can control who can access that. But what you find is that in organisations, people with that data around, and suddenly find you've got no control over it. It happens. With the challenge you've got with the vector databases, where you're creating different sources of data, you can lose control in that you might set up guardrails, or you're not setting up guardrails, where some personal information leaks into it, but you don't actually realise. And because it becomes widespread, where people are just asking questions using Claude or whatever, then suddenly you find that unexpected data starts to appear because people are asking questions of that data that you wouldn't normally expect.
That's on the data engineers to set up the models appropriately.
Absolutely.
Yeah,
It's not just the data engineers, it's the guardrails that need to be.
The whole IG system in the organisation around how that's set up and the appropriate management of data.
I agree, but how do you monitor? Let's say, for example, someone decides.
Where 27001 comes in and various other things. And I know they're a bit behind the curve, right? But the controls, and any organisation has got to prove that it's in control of its information.
It has, it has. But what I'm saying is that it can be a bit more complicated, where it's harder to understand where that data is coming from because it can become quite convoluted.
Okay. But so you add layers, but in the, I think we're both saying the same thing. I'm sort of inferring that I've got an organisation that's in control and looking at all these things, because I'd be making sure in my organisations that they do.
How you set up that governance layer.
It's exactly about governance.
So that you can say, okay, well, if I'm using that database, that vector model, whatever, LLM, the data sources that are all
I'd be testing it and
not just testing it, but it's changing constantly. So just making sure that alarm bells go off and any questions that shouldn't be asked by the wrong people are being picked up on.
I think it's fair to say though that as the tools are becoming more user friendly to get to the data, somebody's mapped it, and the mapping gets mapping's incorrect or mistaken, or there's been an error made, then there's an easier chance of it becoming. It's almost
not convoluted. It's that black box thing where you're thinking, well, okay, where is this coming from?
Yeah.
So if I may, this does raise another very interesting point, which is that there are lots of ontologies which already exist, which are meant to represent this kind of data that you're describing. So we've spoken about creating our own ontologies, but actually there are many ontologies that already exist. There are loads in the life sciences domain. There are loads in social networks. Google has its own ontology called schema.org, which basically represents everything. But you could use something like Provo, for example, which is the provenance ontology, to represent the lineage and provenance of data that goes through your system. So at least then you could know whatever the information it is that I am looking in the graph, I know where it came from and I know when it did it and what put it in.
And that's what you do in a good organisation. You'll be checking that, data flow lineages.
Steve has mentioned online, he said, I've seen problems with Office 365 Dell because the end users didn't understand the difference between share with everyone and share with named people. So the point the gentleman's making is it makes it easier to make mistakes with the data, perhaps. But that is, people that drive fast cars can have accidents faster, right? I mean, that's it really. But I think that's it. It's being tool aware, isn't it? And have the skills available. And of course, coming full circle to what I talked about earlier about the BCS and being an IT professional, being somebody that's aware of these risks and these issues, has a code of conduct and is thinking about it.
Exactly.
And ultimately, that's it. I mean, if you give something away by accident, you're still giving it away. And we all know that the biggest risk to data sets, and the biggest risk to exposing of attacks and so on, typically is the human being. So
yeah, but
mistakes.
And language, just going back to the more traditional, you still have data dictionaries that said this is what it means, right? So in the cases of ambiguity, send it to everyone or named. In the old world, you'd have a or the current world even, data dictionary that would explain what that actually meant. And you just have to apply the same technique.
Look at how data dictionaries are evolving now, where you'll use AI to replace that.
Well, that's what I'm saying. That the language may replace that, but you still have that. There's a case where you're going to have something that's ambiguous, so you have to define it to make sure it's ambiguous.
Perfect.
Yeah.
Absolutely. Yeah. So if you're interested in data dictionaries and those kind of products, then have a look at data.world as well. Data.world provides a data catalog based on a graph which has recently been acquired by service.now. As I say, if you wanted to look at existing ontologies, just have a conversation with a language model and ask what's there. You can sort of understand the different dimensions you could put into your graph to know about provenance, lineage, or anything which you might want to reuse. So it's all there. The ontologies themselves follow a standard. So in other words, it's a language. So there's lots and lots of training information already on the language models have been trained on, so they understand these models. So you can kind of do your own research around this stuff in quite an easy way as well, just from having conversations with language models.
Please. Well, we are kind of out of time. I mean, we're 10 minutes over, but I think the conference has been great, really. I just want to say a big thank you to Charles. I mean, certainly it's an area which I'm much more interested to explore. And part of the issue tends to be, well, where do you start? And I think what you've done today has given me, certainly personally, a really good in to the next steps. So that's really helpful. And of course, if those links that come through, that'd be even better. That'd be great, that one. We can distribute those and put those together on it. So I would just like to say a big thank you. We can all show Charles our appreciation. Great. Thank you.